Students, this is a video that I have prepared for the topic trigonometric ratios. Now, in my notes, I have already mentioned that trigonometric ratios are quantities which are formed by comparing the dimensions of a right angle triangle with respect to a certain angle. And over here also, I have made a right angle triangle which is having the vertices as A, B, C. This is a triangle. And in this triangle, there is one angle which I have labeled it as theta. We read this symbol as theta. So on the vertex C, the angle theta, with respect to this angle, we are going to first label the different sides. So always remember that the side which is opposite to the given angle, that side is always considered as the perpendicular. The side which is opposite to 90 degree is always considered as the hypotenuse. And the side which is adjacent to the given angle, that is considered as the base. And once we have figured out all the different sides, the name of all the different sides, then you can frame the trigonometric ratios. There are 6 trigonometric ratios. The first one is sine theta, which can be written as perpendicular upon hypotenuse. Second one is cos theta, which is equal to base upon hypotenuse. The third one is tan theta, which is equal to perpendicular upon base. Fourth one is cosec theta, which is equal to hypotenuse upon perpendicular. And you can also call that cosec theta is actually the reciprocal of sine theta. Similarly, the fifth one is sec theta, which is hypotenuse upon base, and this also is a reciprocal of cos theta. You can see it over here. And the last one, the last trigonometric ratio is cot theta, which is base upon perpendicular, and this is also the reciprocal of tan theta. So cosec theta is a reciprocal of sine theta, sec theta is a reciprocal of cos theta, and cot theta is a reciprocal of tan theta. Now, I've taken a few questions from the first exercise, that is exercise 1.8, where we have to find out the value of certain trigonometric ratios. In this third question, they have given us a right angle triangle, which is right angled at the vertex A. And they have given us the length of line segment AB as C and the other line segment AC as B. And we have to find out the value of tan B, tan C, sin B and cos C. Now in place of theta, they have given the vertices over here with the different trigonometric ratios tan, sin and cos. So for every different vertices, the value of perpendicular and base will get changed. But before that, we have to find out one more thing. Because we know the length of this side AB as C and the length of this side AC as B, with the help of Pythagoras theorem, which can be applied in a right angle triangle, we are going to first find out the value of the hypotenuse. As I told you earlier, that the side which is opposite to the 90 degree angle is called as the hypotenuse. So this BC side will be acting as the hypotenuse over here. That is fixed. We are going to figure out the value of this hypotenuse. So as per to the Pythagoras theorem, you know, perpendicular square plus base square is equal to hypotenuse square. This is the equation. In place of perpendicular and base, either we take B as perpendicular, then C will be considered as the base, or we take the perpendicular as C and the base as B. That also will be correct. Because over here, perpendicular and base are the two sides which are forming this 90 degree angle at the vertex A. And because they haven't specified any angle over here right now, so we can take either of the two sides as one as perpendicular and the other side as base. So I've taken this AC as the perpendicular and this AB as the base. So AC length is B. So in place of perpendicular, I'm going to write B, and the square of B will be B square. In place of AB, I'm going to write C, and the square of C will be C square is equal to H square. Now, In order to find out the value of h, that is hypotenuse, I'm going to remove the square power, and on the other side you will place the square root sign. So the value of h will come out to be under root b square plus c square. Now once we have got the value of hypotenuse as under root b square plus c square, now we are going to figure out the values of the different trigonometric ratios. So the first trigonometric ratio is given as tan b. Now in place of theta, we have to find out the value of this trigonometric ratio tan with respect to the angle b. That means over here, with respect to this particular vertex b, we are going to figure out which side will be considered as the perpendicular and which side will be considered as the base. So as you know, with respect to this b vertex, if we see the side which is opposite to the b vertex, that is AC, that will be considered as the perpendicular, and the side which is adjacent to this b vertex, that will be considered as the base. So as we all know that tan means perpendicular upon base, and by taking this angle which is at the vertex B, AC length is acting as a perpendicular. So in place of perpendicular, we will be writing B. And as far as base is concerned, as you know that the side which is adjacent to this angle, that is AB side, that will be considered as the base. So we will write C. So the answer for tan B will be B upon C. Similarly, if we take it out for tan C, for this trigonometric ratio, but this time the angle has been changed, it has been moved to the other vertex, that is C. So with respect to this particular vertex, we are going to figure out which side will be acting as the perpendicular and which side will be acting as the base. So if we take this C vertex, then the side which is opposite to this C vertex, that is AB, will be considered as the perpendicular, and the other side which is adjacent to the C vertex, that will be considered as the base. So AB will be the perpendicular with respect to this angle at the vertex C, and AC will be acting as the base. So again, perpendicular upon base, this time it can be this side is the perpendicular with respect to this angle, so I'll write C over here, and this side is the base which is adjacent to this angle at the C vertex, that will be B. So the answer will be C by B. Similarly, if we see for the other trigonometric ratio, that is given as sin B. So the answer for sin B will be, as we all know that sine of any angle is perpendicular upon hypotenuse. But this time again we have to see with respect to the vertex B. So just now, with respect to the angle that is present at vertex B, we have figured out that AC length is actually acting as a perpendicular. So in place of perpendicular, we will write the value B, and we know that sine ratio is composed of perpendicular upon hypotenuse. So in place of hypotenuse, we will write the value under root B square plus C square. So the answer will be B upon under root B square plus C square. Similarly, for the last part, that is cos C, as we know, cos ratio is formed of base upon hypotenuse. But again, we have to judge the different sides, perpendicular and base, with respect to the angle that is at the vertex C. So at the vertex C, this angle with respect to this angle, the side opposite to this, that is AB, this will be considered as the perpendicular, and the other side will be considered as the base. So because this is the perpendicular and this is the base, and cos trigonometric ratio is composed of base upon hypotenuse. So that means because AB side is acting as a perpendicular with respect to this angle, and AC side is acting as the base. So in place of base, we will write B, and in place of hypotenuse, we will copy the same value of the hypotenuse, which is the side opposite to the 90-degree angle, that is under root B square plus C square. In this way, we will get the answer. If you see the next question that is given, that is the 11th question that I have taken, which says that if cos theta is equal to 24 by 25, then find the value of sin theta, tan theta and sec theta. Again, we will be needing a small help, but before that, we have to understand one thing, that cos theta they have given as 24 upon 25, and we all know that cos theta is the ratio between base and hypotenuse. That means this value will be considered as the base and this value will be considered as the hypotenuse, because cos theta is a trigonometric ratio that is composed of base and hypotenuse. So by Pythagoras theorem, again we are going to write the equation p square plus b square is equal to h square, that is perpendicular square plus base square is equal to hypotenuse square. In place of p, I am going to write p only, p square. In place of b, I will write 24, which I figured it out from here, 24 square, and in place of h, we will write 25, which I figured it out from here. So 24 square is 576, 25 square is 625. So the equation is p square plus 576 is equal to 625. These two are like terms. Bring this thing on the other side by transposing. So p square will be 625 minus 576. P square is equal to 49 on subtracting, and therefore on removing the square power and placing the square root sign on the other side, you will be getting the value of p as 7. So that means perpendicular is coming out to be 7. Now we are going to figure out the value of the different ratios. Like the first ratio is given as sine theta, and we know that sine theta is a ratio between perpendicular and hypotenuse, and we know the value of perpendicular is 7, so that will be 7 upon 25, because 25 is the hypotenuse, which we have figured it out from here, from the given trigonometric ratio. Tan theta is perpendicular upon base, so perpendicular we already know that is 7, we write 7 over here, and the base we also know from the given trigonometric ratio, that is 24, so we write 7 upon 24, that is our answer. And the last one is sec theta, which is actually a reciprocal of cos theta, as I told you earlier. And sec theta is hypotenuse upon base, so the value of hypotenuse is 25 and the value of base is 24, so the ratio will be, the answer will be 25 upon 24. In this way we are going to do these types of questions.